On Friday, April 13th, 2029, a shadow will fall upon Earth. Not just any shadow, but the shadow of asteroid 99942 Apophis, a 1,100-foot wide space rock hurtling through the cosmos. For a brief few hours, Apophis will be closer to Earth than some of our satellites, a mere 19,000 miles above our heads, a distance that is cosmically insignificant. This close encounter, visible to the naked eye, will be a stark reminder of the vastness of space and the very real threats that lurk within it, hidden in the darkness. The year is 2029, a year that will be remembered for this cosmic event. Across the globe, people hold their breath as a point of light streaks across the night sky, a celestial visitor. It's not a shooting star, but Apophis, a remnant from the early solar system, making its closest approach to Earth. For a few heart-stopping hours, our planet will be at the mercy of cosmic forces, a celestial game of billiards where the stakes couldn't be higher, reminding us of our place in the universe. The consequences of an asteroid impact are hard to fathom. The energy released would be equivalent to thousands of nuclear bombs detonating simultaneously. Imagine a shockwave that could level entire cities, tsunamis towering hundreds of feet high, and a global dust cloud that would plunge the Earth into darkness for years. The impact would trigger earthquakes and volcanic eruptions, reshaping our planet's surface. The skies would rain fire, literally, as molten rock ejected from the impact site falls back to Earth. The long-term effects would be even more devastating, with the potential to trigger an impact winter, disrupting agriculture and threatening the survival of countless species. Asteroids are rocky remnants left over from the early formation of our solar system about 4.6 billion years ago. These ancient objects provide us with a glimpse into the building blocks of our cosmic neighborhood. These celestial bodies, ranging in size from a few feet to hundreds of miles in diameter, come in a variety of shapes and compositions, each telling a unique story of the solar system's history. They orbit the Sun in a belt between Mars and Jupiter, known as the Asteroid Belt, where millions of these objects can be found. Most asteroids are harmless, but some, like Apophis, have orbits that intersect with Earth's path, posing a potential threat to our planet. Scientists closely monitor these near-Earth objects to predict and prevent possible collisions. The size of an asteroid determines its potential for destruction. Larger asteroids can cause more significant damage, while smaller ones are less threatening. Small asteroids, those less than a few meters across, typically burn up in Earth's atmosphere, creating a brilliant fireball known as a meteor. These events are often spectacular to witness. Larger asteroids, however, can survive atmospheric entry and cause significant damage upon impact, potentially leading to catastrophic events. The dinosaurs, for example, are believed to have been wiped out by an asteroid impact 66 million years ago. This event drastically changed the course of life on Earth, highlighting the profound impact these celestial bodies can have. Discovered in 2004, Apophis quickly gained notoriety as one of the most potentially hazardous asteroids ever detected. Initial calculations suggested a small but significant chance of impact with Earth in 2029. However, as astronomers gathered more data and refined their observations, the risk assessment changed dramatically. We now know that Apophis will not hit Earth in 2029, nor will it pose a threat for at least a century. While the immediate threat from Apophis has been averted, its close approach serves as a stark reminder of the importance of planetary defense. Space agencies around the world are actively monitoring near-Earth objects like Apophis, developing technologies to deflect or destroy potential threats, and planning for the possibility of an impact event. Section 5. Eyes on the Skies. Early Warning Systems. To protect ourselves from asteroid impacts, we need to be able to detect them early. Early detection is crucial for taking timely action. Several ground-based and space-based telescopes are dedicated to scanning the skies for near-Earth objects. These telescopes are our first line of defense. These include the Lincoln Near-Earth Asteroid Research or LINEAR project, the Catalina Sky Survey, the Panoramic Survey Telescope and Rapid Response System, also known as PANSTARRS, and the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Each of these projects plays a vital role in our planetary defense strategy. These systems work by taking repeated images of the sky and looking for objects that move relative to the background stars. This method allows us to track the movement of potentially hazardous asteroids. By analyzing the object's brightness and movement, astronomers can determine its size, orbit, and potential threat to Earth. This data is crucial for assessing the risk and planning any necessary interventions. The sooner we detect a potential impactor, the more time we have to prepare and potentially deflect it. Early warning systems are essential for safeguarding our planet from these cosmic threats. Section 6. Planetary Defense, Deflecting the Threat. Once a potentially hazardous asteroid has been identified, what can we do about it? Scientists are exploring a range of planetary defense strategies, including kinetic impactors, gravity tractors, and nuclear options. The goal is to slightly alter the asteroid's trajectory, enough to cause it to miss Earth. Kinetic impactors involve crashing a spacecraft into the asteroid at high speed, transferring momentum and slightly changing its course. Gravity tractors, on the other hand, would use the gravitational pull of a nearby spacecraft to gently nudge the asteroid off its trajectory over time. Nuclear options, while controversial, are considered a last resort if other methods fail. Section 7. DART, a test run for planetary defense. In 2022, NASA successfully tested its first planetary defense mission, the Double Asteroid Redirection Test, or DART. The DART spacecraft intentionally crashed into the small moon of asteroid Didymos, demonstrating the feasibility of using kinetic impactors to deflect asteroids. The DART mission provided valuable data on the effectiveness of kinetic impactors, paving the way for future planetary defense missions. By studying the impact crater and the change in the moon's orbit, scientists can refine their models and improve the accuracy of future deflection attempts. Section 8. Safeguarding our future. The threat of asteroid impacts is real, but it's a threat we can mitigate. With advancements in detection systems, planetary defense technologies, and international collaboration, we are taking proactive steps to safeguard our planet from cosmic hazards. The close approach of Apophis in 2029 serves as a reminder of the importance of continued investment in space exploration and planetary defense. As we continue to explore the cosmos and push the boundaries of human ingenuity, we can face the future with confidence, knowing that we are not just passive passengers on this pale blue dot. We are active guardians of our planet, working together to ensure a brighter future for generations to come.